Good afternoon, everybody. Welcome. Wednesday Tech Talk lunch. Thank you, everybody, for coming. Hope everyone's got food. Anybody that does not have food? Anybody needs food? We're all good on food? Okay. Please tip your servers today. Lisa's over on the other. Thank you, Lisa. Okay, so today we actually have a guest speaker who's in from out of town, and by out of town I mean Chile, South America. Welcome. I think he's our furthest traveler Tech Talk speaker that we've ever had at the Tokyo office. His name is Juan, and he's here to talk about the Swift Summary Talk, but more specifically playgrounds in Swift and Swift 3. So without any further ado, Juan, we're really excited to have you here. Thank you for coming, and we're all looking forward to your talk.
Well, thanks. Thank you very much, Derek, for that intro, and I'm very pleased to be here today with you and Pivotal. I also want to say thank you to Hadrian Rafali that also helped coordinate and organize this. And of course, Derek, thank you very much for everything that you've done to arrange this. And also the iOS Tokyo meetup that I had the privilege to talk at. So without further ado, I'll get right to it. As Derek mentioned, the context for this talk is, I'll just get right started with more context. So basically, this is me. As Derek told you, I'm a software engineer from Santiago, Chile. But on top of all those things, I've been doing many other things in different areas, like engineering. I've been also a musician and music producer for a long time. You can check some of my tracks on Spotify and all the streaming services. And I infrequently write on my own blog, and I mainly talk about tech and music and everything related to software. In my software career, I've been mainly developing applications for the iOS platform since 2011, which is where the whole boom of applications kind of started. And in that period of time, I've been very happy to develop many applications for smaller companies, for bigger companies, but most importantly, have been involved in certain projects that have done very well and have charted #1 on the App Store and in different other rating sites. And last year, I went on the personal mission of upgrading myself completely to Swift in terms of writing in that language, just to know how many software engineers do we have in the room right now? Okay. And designers by any chance? Okay, great. So this talk is, I'm going to say, moderately, slightly technical, but not too technical to just get people lost. Okay. So last year, what I did was let's get upgraded to Swift completely. And what I did, I started writing a book, a summary book about the Swift language. Now, Apple gives you all the documentation as a static PDF, and that, as a software engineer, many software engineers will tell you, that's not the most fun and great way to learn a programming language. You want something that's interactive, that you can tinker around, that you can basically break it and make it your own. And that's exactly what I did, which was creating a summary book that is written on the Playgrounds platform, which is basically a scripting platform that allows you to just test code right away. And it's very interactive. And apparently the community liked it because on the launch of the book, I launched it on the Product Hunt platform. And who knows Product Hunt here? Okay. Well, it's based, for those of you who don't know, Product Hunt is like the best way to launch a new tech product and get traffic to that product. It's a very engaged community, and it's great for these kind of things. And it actually, the book was featured on the books category, not even in the apps section, and it actually broke records for over 280 upvotes. That is kind of a record in the history of that category itself. And on GitHub, it was able to get more than 1,500 stars, which was incredible. And of course, a lot of support from companies like eBay, Amazon, Groupon, and other engineers working at bigger companies. So there was clearly a great demand for this kind of resource and a lot of interest in getting something that was easy, that was faster to read in order to get upgraded to language. So that's when I decided to release it, and it's available for you, for everybody, as an open source project. You can just go to swiftsummary.com and you can clone the repository from GitHub. So what I want to talk about is a little bit of some things that I really like about the platforms that I used to write the book and how that affected the writing of it. So it's basically to share with you some of those insights. So first of all, I want to talk about playgrounds from the people that are, software engineers. Who knows about playgrounds? Wow, okay, that's cool. So as the definition goes, playgrounds is a place where people can play. And that's exactly the kind of concept that the platform wants to transfer to everybody, which is a platform that you can use for testing code, for writing snippets, for writing or iterating over code that is isolated from the main application, so you can basically improve it and then add it to the main project. And basically nowadays it's also used for writing educational material, tutorials, and a lot more things. So it's great for this niche of use cases that is increasingly growing over time. Some of the features that I really, really love are, for instance, pagination that they have. So when I first wrote the book, it was literally a folder with individual files that each file was the chapter, a corresponding chapter. Now, navigating through the book was a little bit time-consuming because you were having to open and close all these files at the same time. So pagination actually allows you to create just one Playgrounds file and have different subfiles that each one represents a specific chapter or a specific resource that you want to show. So the great thing is that you just open one file and you have all the resources right there. It's very convenient. Second feature that I really like is access level. So for every page in Playgrounds, you have a dedicated folder with sub-resources or source files that you can use, but that are just available for that page in particular. So if you're just writing, let's say, a specific tutorial, you can add specific resource files that are just available for that tutorial, but you're not going to be messing around with other pages. Third feature that I really like is what I call inline printing, which is whenever you start, let's say, executing certain commands, you will have kind of a live preview of what you are writing. So let me show you that real quick with an example. Just gonna mirror this a little bit. So let's go here. I have a exploring San Francisco example, which what it does is basically tries to find the shortest route from, I guess it was markets, the main market to the airport, but going through different locations like the Moscone Center and the tower and the Golden Gate Bridge and other places. So let's make this a little bit bigger. Yes. Okay. Yeah, it works. So basically here we have, we are not going to focus too much on the details, but basically there are a lot of executions here that are happening, like iterations or loops. And you can see here that there are previews. You can actually tap here to close or open the value of certain iterations that are happening in real time. So whether you're calculating numbers or you're doing like a graph or just dots in space, it's very useful to see a visualization of what's happening. Here, for instance, I think it was here, yeah, the best travel time is being calculated over time, and whenever there's a new value, this graph is going to be updated. So it's very, very useful to get that kind of preview, and also you can get some sort of preview on objects like collections or dictionaries. So here, for instance, I have an object that has an image association to it. So you can start diving into the details of what's being shown there. That's very useful for that kind of use case. So that's inline printing. You also have live views. And live views is really, really cool because it allows you to basically have a real-time preview of interface, of user interface. So if we would take a look at that real quick. In the same example of San Francisco, if I actually try to execute that one more time, I can open this little tab here, which is like the assistant editor, and I can have a split screen with a view of the map of San Francisco and the routes being calculated in real time. So these are all numeric values that are being calculated and iterated, but since I'm updating a view from a view controller, I'm able to basically preview this on this assistant editor. So it's much more visual to see the result of that iteration. And at some point, all the lines are going to get to green when the optimal route is found. This is actually very it's kind of time consuming, so I think they developed a separate version of it, which is a lightweight algorithm that will go just faster into the route. It takes like considerably less time to get there. There you are. So it's really great. So whether you're doing games, you're testing specific object positioning, it's really great to test that kind of thing. And just not going to go through. The other thing that I wanted to show you is markup. Markup is really great for documentation. So to get to the point, one of the things that happens is that when you're writing code, this is my personal opinion, you have what's the code, the real code, but you also have comments. And comments are really useful for other people and for yourself to really understand what's the thinking behind a certain execution or a certain command line, right? Now the problem of that, this is visually, the comments look like code because they're in the same font, almost the same structure. Although they have a different color, but the whole page feels like it has more code. If you actually go through it, it's like, okay, there's a lot of content here. So Playgrounds, in the spirit of actually turning Playgrounds into an educational platform, they have implemented their own markup language that you can see here with this notation. So the cool thing is that here is the raw render, but you can actually go to, for instance, the editor section, and show the rendered markup. And when you click that, automatically it renders a beautiful styling of that markup in kind of the format of a book. So you have headers, you have note sections, you have paragraphs, and you can see that before going into the code section, there's a big space. So yes, the document itself, it is larger in the extension, like in the scrolling, but it is way more clear to see where the real code is and where just the comments are. And I think that it makes it visually more appealing and a little bit more understandable. So now to the next section of the talk is Swift 3. Who has been tinkering around with Swift, first of all? Okay, who has been tinkering around with Swift version 2? Who's been doing Swift version 3? Okay, so it's kind of a split situation. That's great. So there was a period of time in which I had to transition from Swift 2 to Swift 3, especially for the writing of the book. And I think it was very interesting to see some of the changes and some of the proposals that were accepted to improve the language. And I want to share with you some of those changes that I think are very interesting and will make programming in Swift a lot more fun, a lot easier. So Swift 3 actually focuses on two things, in my opinion, which is clarity and less redundancy. First of all, I'm going to do a flashback to once upon a time, we had Objective-C for writing apps. And Objective-C was very verbose and not really intuitive. For anyone that has actually used programming languages before, like Java or even Ruby or other kind of languages, this looks nothing like it. And it's really counterintuitive, and it can't puzzle many software. It actually puzzled many people. It was like an entry barrier. And you have a lot of elements that are not really intuitive, like numbers are preceded by elements that you don't really understand. Names of methods and functions are really long. It's really ugly in that regard. The same thing applies for when you wanted to declare a function, which is basically something that makes no sense. Parameters had huge names. It was really not pretty. So Swift comes in, and now Swift 3 actually focuses on brevity and less redundancy. So let's take a look at some examples in Swift 2. In order for you to actually create a collection or an array, first of all, it already looks much more appealing than Objective-C. It's something like you've seen in other languages. It's dynamic typing. You just have the numbers. You have the collection. It's really comfortable. But you still have carry-on behavior from Objective-C. You have huge names for functions, like append contents off, remove at index. And the problem with this is that in every other language, you have the generic method, which is append or remove, and then you would have an override or a different definition for specific parameters. And at this point, that was not the case. So Swift 3 improves that by saying, okay, what we're going to do is actually that. We're going to make the standard for those methods, and any kind of variation is going to be on the parameter itself. So now it looks even more like other languages you've worked with. Other example, you could do insert, but again, parameters, in this case, this example is a little bit redundant. Why? Because you're still, when you say, I'm going to insert something in a collection, in this case you're passing the element, but it's pretty obvious in this case that you're going to insert it at an index. So it's a little bit redundant to keep specifying at index. Things like that have been removed in Swift 3 to basically just cut to the chase and say, well, when it's obvious, we don't have to just keep repeating ourselves. The same thing applies for dictionaries. Again, we have the same example, remove value for a key, too specific, we would need different definitions for methods. That has been changed in Swift 3, creating a standard method. This is a fun example with URL. We have different definitions, the same mistake, the same pattern here of too long methods. Who's used this before? Okay. Can you tell us what does this call do? The second line. Please go ahead.
You have an SURL, you're calling something, I assume with file // right? You're returning an SURL. You're getting the URL out of that by calling file URL.
So it will modify URL?
I think it would just take the URL you've given it, and I think it would append file // to the front.
Okay. Okay. Okay, cool. That's exactly why that has been removed and changed in Swift 3. Because that is the intuitive way of thinking. But actually, that returned a Boolean value. And it was basically to find out to basically query, is this a file URL? So it is clear, there are clear improvements that you can make in terms of semantics and to understand better what's going on by just reading the lines, not even going to the documentation. It's just I want to read what's on screen and understand what's happening. And that's what's been going on in Swift 3 to basically clarify all of the things in the language. A little bit on clarity. So here's the function that's been defined. And then afterwards, I have a call for that function that's right below. Now, in some cases, I define a function, and I'm not really interested in the return value, but I'm really interested on what's happening inside the function. In this case, printing or doing anything with A. But this is like the perfect world because I have the function and then I have the call right below, so I can look it up right away. But that's usually not the case. So you will find many times that +1 for randomly in the code, anywhere. So you will ask yourself, what is this doing? Why is this here? And it's not clear there that you're just interested in the operation. So in order to make it more clear, they actually allow you on Swift 3 to add an underscore to specify clearly, I do not care about the return value, so the function is really doing the job in the background. Things that really improve things for the reader. Language clarification. They also added, going into more detail with language, they added conveniency into, okay, depending on the tense in which the method is written, you will understand different things. So the conventions in this case is if you use reverse, it's going to change the value of array. If you use reversed, it's basically going to give you a copy with the changed value. The same thing applies for append or appending. So just by reading the method, you can understand what's going on behind scenes. So I want to talk about a little bit Swift evolution. Swift evolution is basically proposals that you know that Swift language has been open sourced for the community. So anyone can basically propose a change and then will be evaluated, will be reviewed, and it will get rejected or approved, and it will be incorporated into language. You can actually check all the proposals there in that repository. And I just want to share with you some of the proposals that I think are really cool. First of all, consistent parameter labeling. What is that? Well, in Swift 2, you had the definition of the function with labels A, B, C. But a carry-on from Objective-C is that it is not necessary to mention the first label of the first parameter, the label of the first parameter. And that, right now, is not very consistent. So in Swift 3, they actually tell you, okay, if there's a label, you get to mention it. Consistent. Plus plus and minus minus operators are going away. And that's kind of a shocker for many software engineers. Like, what? It's been going around, they have been around for years. And what happens is that you would usually, this is like a very typical operation, usually in iterations like for loops, you would have I++ or value++. And the thing is that right now in Swift, it doesn't really, because of another thing that we're going to see in just a moment, it is not very clear, it's not very intuitive, the plus. It is very convenient, it is kind of cool to use it, but in terms of clarity, it's not really clear that you're adding 1. On top of that, why is there a plus and not a plus or a plus and so on and so forth? You just have that call. And it is just, if you're designing Swift, it just doesn't, what they call it, doesn't look Swifty. So in Swift 3, they actually eliminated the plus and minus operators, and then you have to specifically use plus equals and the number that you want to add. Collection indexing. So a cool thing that you had in Swift 2 is that you could basically get an index for an array and then call for its successor. Now, the problem here is that in this case, the I variable is usually being used to go through the array, right? Iterate over the array. But the problem is that successor operates in the integer or the numeric value. So there's no relationship between successor and the bounds of the array. So it is very likely that you could actually make a mistake and go out of bounds. So what they did is that eliminated that, and now they're putting the context into the collection. So now you ask for the array to give you the following or the previous value for the specific index you're passing. And that way, you're making sure that you will always be within bounds. Another one that's related to the minus minus and plus plus operators is that C-style for loops are gone in Swift 3. So Swift 2 allowed you to do the typical for loop, the classic one that you know for any language. Now, if you're new to software engineering or coding, and you're entering this realm, this actually does not look intuitive at all. Like you have semicolons, you have 3 executions in a row, you have this operator here, and it's like you have, okay, we start with that, until that point, we first go through the loop, and then we get to this point. What kind of logic is that? It is really, it looks hard for a newcomer. So, for clearer purposes and for syntax purposes, they have eliminated this way of going through loops. And now you can only go for the for-in kind of structure. So what this does is that it is much more clear what I'm doing, and I'm always bound to the array. I'm always bound to, okay, as long as I'm inside the array. It is also shorter, which makes it visually more comfortable. And because this is also going away, they said, well, if this is going away, the plus plus operator doesn't really have a lot more context outside of this kind of operation. So it's like 2 birds killed in one shot.
How about the previous one on the previous screen?
I'm sorry?
So why did it change the previous one as well to get the next index in the array if they are going to get rid of iterations? Of course, the previous screen.
Previous. So this
Yeah,
one?
so why do they improve collection indexing if they don't try to discourage it? This is only helping for the for loops. This array that index after 9. Right. This is
Oh, yeah.
So if they are getting rid of normal C-style for loops,
Yes.
why are they doing this?
Why are they adding the array.index
Yeah.
after before?
Because they just removed the usage of it.
Yes. Well, it's actually a good question. It's like they improve. This is mainly an improvement of something that was not related to something that is related to the array. Now, if you ask me what's the usage of this, I agree with you. It's quite limited. There might be use cases to use it, but it's arguable. I totally agree with you. Now, the cool thing about this is that you're asking the array for the information and not randomly adding numbers. But yes, I agree with you. It could be arguable. And who knows, they might actually delete it in the future. Floating points. Swift 2, you can ask for mathematical functions or mathematical numbers, right? So give me a pi. Now, when I look at this, I don't know, because now we're using type inference, I don't know what I'm getting with that call. Am I getting an int? Am I getting a float? Am I getting a double? What am I getting with that? It's not clear right away. So that's why they made the improvement of, okay, now I'm going to ask the type, the specific class, to give me a pi. And that's great, because from reading the line, I know I'm going to get a double, or a float, or an integer. Who's been using in-out? Has been someone using in-out here? Okay. So in-out is basically a way to, so for safety purposes, or for declaration purposes, parameters that are passed to a function cannot be modified inside the function. You would have to declare a new variable to get that value